Welcome students, this is Professor Pushkar Shinde. Today we will be discussing switching to protected mode, part of the Unit 5 of Microprocessor. When we are switching to protected mode, we have to set the PE bit of the CR0 register, that is the machine status word, to 1. The CPL starts at 0, current privilege level, when the processor is switching from real mode to protected mode. Segment registers continue to point to the same linear address as in real address mode. Immediately after setting the PE bit of the CR0 register, the initialization code has to flush the processor's instruction prefetch queue by executing a jump instruction. So the prefetch queue has to be flushed when the processor switches from real mode to the protected mode, and that is done by executing a jump instruction by the initialization code. The 80386 basically fetches and decodes instruction and addresses before they are used. So that's why the prefetched code has to be flushed by executing the jump instruction. The next part is the software initialization for protected mode. Most of the initialization that is needed for protected mode can be done either before or after switching. That means before switching from real mode to protected mode, the initialization part can be done, or after switching from real mode to protected mode, the initialization can be done. The initialization procedure must not use protected mode features that are not yet initialized. So the initialization procedure should not use protected mode features like paging, multitasking, segmentation. These features cannot be used till they are initialized basically. The next part is initializing the IDT. As you all know, the IDT contains the entries for the different interrupts, and the entries in the IDT point to the valid interrupt routines in the memory. So whenever you are switching from real to protected mode, the IDTR has to be initialized. So IDTR may be loaded either in the real mode or protected mode. However, the format of interrupt table for protected mode is different than that of real address mode. So it may be possible that IDTR has been initialized in the real mode. So when you switch from real mode to protected mode, the interrupt tables may have invalid entries. So if the interrupts are called, then it may be possible that wrong execution may happen. So for that, it is preferable to disable interrupts till the IDTR is properly initialized. So that is the important part. There can be unpredictable results if interrupts or exceptions occur at a time when interrupt table has not been properly initialized in the protected mode. To avoid this unpredictability, interrupt should be disabled until proper interrupt handlers or interrupt routines are mapped in the IDT that has been created in the protected mode. The next part is the stack initialization. In the initialization part in the protected mode, the SS register may be loaded in either real address mode or protected mode. So SS can be initialized even in the real address mode. So if loaded in the real address mode, the SS continues to point to the same linear base address after the switch to protected mode. So SS register needs to be initialized for using the stack related instructions in protected mode. But if the SS is initialized in the real mode itself, it may continue to have the same address even in the protected mode. So if you have done that, then you can use the stack related instruction in protected mode. The next part is global descriptor table initialization. So to initialize the global descriptor table, you have to initialize the GDTR which has to point to a valid GDT. So before any segment register is changed in protected mode, the GDT register must point to a valid GDT. You know how the GDTR register, that is global descriptor table register, is a 48-bit register which contains 32 bits of base address of GDT and 16-bit limit of GDT. So this GDTR should point to a valid GDT in the protected mode before the segment registers load the selectors. So initialization of the GDT and GDTR may be done in real mode also, or it may be done in the protected mode. The GDT as well as the LDTs should reside in RAM. That is important. They should be in a valid memory location so that the GDTR points to a valid GDT in the memory. The next part is the page tables initialization. So it is related with paging. You all know that paging can be used only in protected mode. It cannot be used in real mode. So the page tables and the PDBR. The PDBR is located in the CR3 register. They can be initialized in either real address mode or in protected mode, but paging cannot be enabled in real mode. Paging can only be enabled in protected mode by setting the PG bit of CR0 register. So paging can be enabled only in protected mode, it cannot be enabled in real mode. But page tables and PDBR can be initialized either in real mode or in protected mode. PDBR is the page directory base register which points to the base address of the page directory. PG may be set simultaneously with PE or later. So PE protection enable and paging bit can be simultaneously set, or you can switch from real mode to protected mode and then enable the paging by setting the PG bit. But when PG bit is set, the PDBR must point to a valid address of the page directory. So valid page directory address must be loaded in the PDBR before the PG bit is set. Initialization procedure should adopt one of the following strategies. The page that is currently being executed should map to the same physical addresses both before and after the PG is set. So the page should map to the same physical addresses in the memory both before and after the PG is set. PG is set to enable the paging, and a jump instruction should immediately follow the setting of PG. So there should be a jump instruction immediately after setting the PG bit of the CR0 register. The next part is the first task initialization. Since multitasking is supported in the protected mode, so we need to initialize the multitasking part also. So before the first task switch, the following conditions must prevail in the protected mode. There must be a valid task state segment TSS for the new task. So there should be a valid TSS for the new task. The stack pointers in the TSS for the privilege levels numerically less than or equal to the initial CPL must point to a valid stack segment. So the stack pointers in the TSS should point to a valid stack segments. So that there should be a valid TSS and proper stack pointers in the TSS. The task register must point to an area in which to save the current task state. So the current task state should be able to be saved in a proper TSS which the task register is pointing to. So current task should be having a proper TSS to save to, Also, new task TSS should also be there. So current task TSS and new task TSS both should be available. Current task TSS will be stored pointed by the task register. After the first task switch, the information in this area is not needed and the area can be used for other purposes also. The next topic in Unit 5 is TLB testing, translation look aside buffer testing. The 80386 basically provides a mechanism for testing the translation look aside buffer, the cache used for translating linear address to physical address. What is the TLB? It is used in paging and it is used to store the mapping from linear address to physical address. So when testing the TLB, it is recommended that paging be turned off, that is PG equal to 0 in CR0 register to avoid any interference by the test data being written into the TLB. So during TLB testing, paging should be disabled by setting the PG bit of the CR0 register to 0. So the structure of the TLB is given in the diagram. Basically, what does the TLB contain is that it contains the linear address to physical address mapping. So for that, the TLB is a four-way set associative memory as shown in the diagram. There are four sets of 8 entries each in the TLB. Each entry consists of a tag and data. Tags are 24 bits wide. They contain high order 20 bits of the linear address, the valid bit, and the three attribute bits. This is the structure of the TLB. There are four sets and each set is having 8 entries each, which is made up of tag and data. The data portion of each entry contains high order 20 bits of the physical address. So this is the TLB that is used by 80386 in protected mode. So I hope you are clear with how to switch from real mode to protected mode, how to do initialization in the protected mode, and what is TLB testing.